Llama 3 has been dominating all of the news lately, but mixture of experts models still have something to stand on. For instance, Mistral's latest Mistral 8x22b is based on this. GPT-4 is in theory built this way. And some of you might wonder if in the open source realm, anyone else has really been pushing the boundaries with what mixture of experts. And recently we saw another incredible example of this. So this latest instance of a huge leap forward in mixture of experts models and tooling comes from Snowflake DB, which is a sort of a data engineering and data ops company. And they've given us something crazy. They've given us what they're calling Arctic 480B128 MoE. So basically a 480 billion parameter model sporting 128 experts built on mixture of experts. And the performance is pretty interesting. And I think it's interesting, especially in context to what we've seen before from companies like Databricks, offering very similar models. And of course, this model is so new that it's not actually on the LM6 leaderboard yet, but I think it's still worth talking about because it's actually changed a lot of maybe negative assumptions that were made about MoE. And I think it's also prescient because right now, Llama 3 was posing the question of whether mixture of experts really was the best way going forward. And it's also cool to see a model that's claiming to be over 400 billion parameters as we wait for the most performant version of Llama 3 400B Plus, to release, with rumors that it's actually more powerful than before and will be open source. So how powerful is this model really? Who can actually run this? Do you actually need 8 4090s? Do you need a pack of 4 M3 Ultra Mac Pros? Is this model actually better than Mixtral or other mixture of experts models? I'm gonna get into all of that in this video. So welcome to AI Flux. Let's get into it. So I think it's worth first going over kind of who or what Snowflake actually is. So Snowflake as a company is a data engineering and ML ops company. Basically, you give them a lot of your data, they help you figure out what you can do with it or what it means, and they kind of coined the term data lake, which is now just kind of a superfluous term of giving some third-party company all of your data and not worrying about hiring your own data engineers. Their whole thing is cloud, that's their whole business, and their reason for open sourcing this and releasing this is really similar to Databricks in that they just want to see if they can actually enable people to do more with their data and have it built on all of their infrastructure, and probably give their balance sheet an excuse to buy a lot of GPUs as a way to backstop what might actually go wrong in the US economy in the next year or so. Because in theory, eventually GPUs will be something better to hold than gold or, of course, dollars. And ironically, if you look at a lot of these companies, they're already set up quite well to host a lot of this infrastructure because they already have vast data centers, they have really fast storage, they have really fast networking between it, and if they can extract more information from this data just using a different tool, for instance, a large mixture of experts model, it benefits them massively. So this is the official release from the CEO of Snowflake, Ramaswamy Sridhar, and this is their first real foray into open source and open source AI. And I think this is a cool direction because even though we're seeing kind of the slow death of corporate contributions to open source, we're also seeing a lot of projects like this open up that are giving kind of a new direction to this model. Basically a way that benefits them, but also I would argue benefits others even more. So here he says, Snowflake Arctic is a state-of-the-art large language model uniquely designed to be the most open, enterprise-grade LLM on the market. This is a big step forward for open source LLMs, and it's a big moment for Snowflake in our AI journey as we continue to build best-in-class enterprise-grade products and add AI to our bio so people will give us more money in our Series D investment round. Now, this is groundbreaking for large language models because one of the key features that Snowflake Arctic focuses on and sets it apart from a lot of others is its use of a unique Dense-MoE Hybrid transformer architecture, which employs obviously mixture of experts and uses this to significantly improve model quality without increasing compute costs. So although, yeah, you see 480B128 expert model, all you can think about is, wow, I probably can't run that on my local 4090. But what's interesting is in theory, based on their claims here, this actually increases its efficiency and makes it cheaper to run. So obviously, mixture of experts is just a neural network model design that combines the outputs of multiple experts to improve performance and efficiency. So basically you pick the best ones going in, you get something out, and it's better than just running it all through one big one of equivalent size. So in theory, based on previous experience with Mistral and others, you would think that not going with a monolithic model and using and splitting inference across several smaller expert models is much better. And in most cases it is. In the case of Snowflake Arctic, the Dense-MoE Hybrid transformer architecture combines a 10 billion dense transformer model with a residual 128 by 3.6 billion MoE layer perceptron, or MLP. This results in a total of 480 billion parameters with 17 billion active parameters chosen using a top 2 gating mechanism. So kind of part of the clip that handles input and then deciding which experts are actually selected. Obviously, this is more complex than that, but that's kind of how it works at a high level. The MoE component of the architecture enables the model to activate only a subset of its parameters for each input, significantly reducing computational requirements without sacrificing performance. Obviously, in theory, Llama 3 will be a monolithic model that will definitely take more GPUs to run, but this is a really interesting case of dense MoE that we haven't seen before. Many but condensed experts with more expert choices really make Snowflake a standout in the MoE space, even compared to what mixture. And this top 2 gating to get to that 17 billion active parameters enables the model to have diverse capabilities while utilizing only a fraction of the parameters for inference. And in theory, that should give us better accuracy and performance. Another big thing that I think is really just not talked about enough with these models when they come from big data engineering companies like this is, although they might not be the fastest, their tooling, generally speaking, is the best. DBRX from Databricks, frankly, was some of the best tooling I had seen in probably 6 months. What this really comes down to, at least speaking about this as a software engineer, is what I would like to call kind of architecture and system co-design. So a lot of these companies leverage a lot of their systems throughput. For instance, really what made Llama 3 possible, and I'm going to talk about this in a later video, is the fact that Meta for basically a decade has been focusing on an open initiative called Open Compute, which basically they said, yeah, we're going to design the best server we can at commodity prices, so we're not paying for like a Dell or HP brand on our servers. We're going to figure out what that is, and then we're going to sell it. We're going to give it away for free, and then allow our board partners to actually use it. And what's funny is, like, the most powerful servers I could afford in college were actually just open compute servers that ended up on eBay, and it was incredible. Like, for instance, it was insane that I could buy a dual CPU motherboard, do kind of a little bit of soldering to make it actually power on, and then have, 64 threads of compute that I paid less than $500 for off of eBay, which was nuts. And because of that, the system design part of that has totally carried over. And the impetus of open sourcing that kind of stuff is the same as it was for hardware 10 years ago as it is now for AI. So the combination of dense and mixture of experts components in Snowflake Arctic enables efficient training by overlapping communication and computation and minimizing overhead. And obviously you can't do any of this unless you already kind of know what your system architecture looks like. And this is why NVIDIA's vertical integration with data centers has so much leverage. And it's why even if AMD was years ahead of where they are now, they still wouldn't be able to catch up, because it's not just the GPUs you make, it's the servers you wrap them around, it's the networking layers that connect all of them, and then the storage you're actually feeding them. So this incredible architecture from Snowflake enables for an effective use of those resources and basically leads to better performance without significantly increasing the amount of wrapper. Now, they mentioned enterprise grade a lot here, and enterprise grade basically means that the cleanliness of the data you're getting out is pretty good, and that you can use it for tasks that basically benefit Snowflake. So in this case, generating really complex, accurate SQL queries, or in certain cases, just completely bypassing them in total. This architecture in Arctic is particularly beneficial for enterprise-specific tasks. When we go over their kind of release here, we'll get into a few more of these. But basically, they've, again, just tailored training data and curriculum to excel in these specific areas. So this is also why DBRX and models like this sometimes struggle in LM6 and benchmarks, because they're massive and they're really capable and they're powerful, but really they're intended for quite a few things. They're not really meant to be able to be great at prose or to be really great at math and coding. These models are really focused on what they're meant to do. And in theory, the reason that these are open source in the first place, I think, is because then these companies say, okay, so we spent, a couple $1 million to have our engineers make these models do these things really well. And then they in theory could pay their engineers to do a bunch of wild things with them. But the benefit of open source and letting anyone touch these and use them and engineer with them is that they get to see all the other things that they probably wouldn't have wanted to pay their own engineers to do, and realize even further capability out of it, even though in theory they gave away millions of dollars of free work. But yeah, in theory, this model should be great at SQL generation, coding, and instruction following in benchmarks. And instruction following, for those of you who don't know, is kind of a early canary for agentic workflows. And I genuinely think that the reason these models are being released is because Snowflake would really like to see some of these experts be tuned to an extent that eventually individual experts could become agentic in nature. And this is without question an architecture that has already been tried and that we're probably going to see within the next 6 months, especially with Google talking up Gato as much as it was in the last week. So I want to jump over to their technical breakdown so we can get a little bit more into the weeds as to how this model works and how good it is, at least as far as Snowflake claims. Now, I'm hoping that Snowflake doesn't juice their numbers as much as Microsoft did with Phi 3. The outcome of Phi 3 was really predictable in that obviously it didn't perform as well as they claimed, now that we actually have some realistic benchmark runs. So let's see what Snowflake had to say about Arctic. So again, they mention top tier enterprise grade intelligence using LLMs coming from the Snowflake AI research team, which is basically just the team that says, let's figure out how to use GPUs, wring more money out of our existing infrastructure and data that's already in Snowflake. It's pretty cool. What I will say is the reason this works for these companies and the way these companies can arise at these huge models is they have a lot of really clean data coming in. In some ways, I would say companies like Snowflake and Databricks are even better positioned than companies like Microsoft, because what these companies build are data pipelines, and a lot of AI in general is just building data pipelines. So what's cool is they don't really have to do as much cleaning work ahead of time and guesswork in terms of what people actually want. And what's cool with these models too is they're really customer focused. Some would argue that Phi 3 is kind of not really fine-tuned to be in any one direction, at least for what a customer would be. And Llama 3, in many ways, is kind of the opposite of this, in that it's designed to be more open-ended, even the Instruct model that was released. Although I think their intent is different, right? Like, Llama 3 was released for very different reasons than this Arctic model, but it's curious to think about and read through. So I think the biggest play that Snowflake is making here is that it's efficiency. It's a huge model that you can in theory run on less infra than you think so. And if you need more, then they're more than happy to sell this to you in a data center right next to one of their huge storage data centers, where they're pretty much trading SQL execution and quote unquote inference with AI enhanced SQL. So they say here that Arctic excels at enterprise tasks such as SQL generation, coding, and instruction following benchmarks when compared to open source models trained with significantly higher compute budgets. So basically they're just pointing at Meta right here. In fact, it sets a new baseline, which we'll have to see if the benchmarks hold up, in cost-effective training to enable Snowflake customers to create high-quality custom models. So in theory, they're melting fewer snowflakes in the Arctic to get better output from their enterprise customers. And they keep saying enterprise needs at low cost. And they might be saying low cost because the economy looks like it's about to implode, but let's see here. Now, what's also cool is Snowflake Arctic is available right now. You can go on Hugging Face and get it. It's already in the NVIDIA API catalog, which means if you want to see us run this on HyperStack, we can do it today. It's also on Replicate right now. And this also shows that NVIDIA is still winning. It just is massively ahead in terms of deploying these models. And of course, it's available on Azure, but I don't know why you would ever use that. Let's look at what they think everyone else used to train their model. So obviously, the most important data point in here for me is DBRX. So they're obviously going to say that this is much better than DBRX, at least in terms of intelligence relative to the amount of compute used. Ironically, DBRX also bragged about how efficient it was when it was created, which is really pretty interesting, but the efficiency gains here are big. I'm going to say that's more of an ESG play than anything else. And they're also saying low training cost. And all they mean here, I think the reason they keep saying this is they want to, quote, enable Snowflake customers to create their own high quality custom models for their enterprise needs at low cost, which I think is also a reason why they open source these, because they can say, look, all these other random people on the internet who don't even do data engineering were able to do it. So we think you should be able to as well. Now, how much time did it actually take to do this? So obviously, it's not surprising that their whole idea here is SQL data copilots, code copilots, and RAG chatbots. It's basically being able to dump a bunch of information in and then use it. So if you're a law firm, if you're an architect, there are all kinds of use cases here. They also use what they call enterprise intelligence, or all of the data their customers have put in, to train this. Now, how much in terms of GPU time and in terms of GPU dollars do they spend on this? So they claim that this only cost around $2 million or less than 3,000 GPU weeks of time. So it's hard to understand what GPUs it actually equates to. Obviously, they probably have access to some of the best hardware in the business, and they have enough money flowing in that they can rent those even if they don't have them in their own data center. Now, with rough performance, Arctic is on par or better with Llama 3 8B and Llama 2 70B on enterprise metrics, which I'd be curious to see what they consider that. And obviously, they're not really going to give us a great definition of what that is. Again, they're big on just looking at the compute budget. Frankly, I don't think a lot of people are really that concerned about compute budgets right now. There's a little bit less slush cash flowing into the kind of AI startup space and AI kind of development space. But to say that there isn't enough money to buy power, I think is an understatement. So right here, they're comparing active parameters. I think the biggest one here is that DBRX, although it has basically a little over 2x the active parameters, doesn't actually benchmark as well. And I think the biggest thing this graph actually highlights is how insanely good LLama3 8B is, just being a monolithic model, because it has half of the active parameters and is performing still within shooting distance of many of these benchmarks. They probably wouldn't like you to think that, but it's kind of interesting. And also, Mixtral is also basically, with their 8x22B model, right in line, and in most cases actually beating Snowflake Arctic. So there's a question as to, although this model is new with their MoE hybrid transformer architecture, there are questions as to really if it's better than other MoE models. You see this massive expert count, you think, oh, this is incredible. But in reality, just to put it plainly, Mixtral 8x22B is just mopping the floor with Snowflake Arctic. Even in the specific tasks they claim Snowflake Arctic is completely dominant in, which is a little bit interesting in my opinion. Again, they talk about training efficiency. I just don't really find that very interesting unless you see performance improvements as a result, at least to a larger degree than we're seeing here. Now, I think this is pretty cool. So what they're showing here is basically a comparison of architectures and how they're built compared to LLama3, conventional MoE, so like Mixtral, Grok, and DBRX, and then Dense-MoE. Now, although Snowflake didn't really see a huge performance boost, there's still some curious things it's much better at. So you can see here that this is basically single direction, right, with Llama 2 and 3. So we have single input and then single path to output. With this other MoE, we have kind of the multi-headed attention again, but there's some level of gating, which is basically how you're picking the experts you want. And with this Dense-MoE hybrid transformer, we basically have just married the two. So there are certain cases where you say, okay, we always pick these experts, there's no reason to go through it. And there's this extra gating phase over on the side here. Now, I would argue what they're trying to get to is a model that makes it really easy to get the benefits of agentic instruction or kind of direction following, and while still having the raw capability of a monolithic model. Because for some reason, there are still things that are just much more performant still going forward with monolithic models. In theory, the idea is that they maintain kind of a mental clarity and sort of a directional of context better than mixture of experts. Because with mixture of experts, you're actually having to coalesce output. And in the other case, you're coalescing output in terms of weights and attention in certain areas of inference. But it's a very different kind of downstream problem. Now, inference efficiency is quite interesting. And they completely admit that Mixtral 8x22B is the most efficient here. And I will say, as someone who's worked with large data centers and sort of larger ML projects, if you talk to data centers, and like I interviewed with and actually almost took a job as an engineer at one of the biggest clouds that operates in the US, which I'm not going to name, but you can guess. It wasn't Hyperstack, since they're not based in the US. But one interesting thing to reference here is that most of the money that these big clouds that run GPUs make is actually made during inference. And they actually lose a lot of money when it comes to training. But they know that in theory, if they train on their cloud, you're probably going to run inference. And this is where the money is made. So I would argue that the biggest play with this is they can say, well, Mixtral 8x22B, that's a cool open source thing, but it's not really enterprise grade and it's not built for existing data pipelines. And now they can say that, yeah, if you run Snowflake Arctic, sure, maybe it's not the fastest, maybe it's not the most efficient. However, when it comes to inference efficiency with how much you're getting per cost per inference cycle, it's one of the best. And this, I think, is the biggest play, which is if you deploy it in your own data center, if you deploy it in a partner data center of Snowflake, you're getting the most bang for the buck, and it's already built for the problems you're already trying to solve. And downstream models will carry the same benefits, which I think is the biggest kind of key for them to turn this into dollars, which we don't talk a lot about here, but I've been getting a lot of comments about people saying that they want to understand more of the kind of unit economics of what's going on here, because that's becoming such a big part of AI. Now, what's also cool, kind of in closing here, is that they've mentioned that they've already integrated NVIDIA Tensor RT LLM, which recently was added to Llama 3. And some curious things that they've actually managed to understand here is that interactive inference of a small batch size, for instance, of 1, has interesting effects on the efficiency of mixture of experts models, in that their inference latency is bottlenecked by the time it takes to read all the active parameters, where the inference is memory bandwidth bounded. So at that size, in theory, Arctic at 17 billion active parameters can have 4 times less memory reads than CodeLlama70B, and 2.5x less reads than Mixtral 8x22B. So basically, this means that there's less host computation having to happen outside of GPU, which means you have faster inference performance. And that's where you get the efficiency. And in theory, if you're using less of a computer that's hosting GPUs, whether it's a DGX or whether it's just PCI, you're probably using less energy too, because you're just having to push bits to less parts of the computer to actually get out the inference to see if your big LLM can write a poem about an Excel sheet you just put in. And what's interesting is they also mentioned that when that batch size increases to thousands of tokens per forward pass, Arctic actually switches from being memory bandwidth bound to compute bound, which pretty much says, in theory, it'll get better with more compute, but we've thrown as much at it as we can, and we think this is a reasonable performance bound. And what's cool is, in theory, the further you push that, the further more efficient it gets compared to CodeLlama70B and specifically Llama 370. So it's sort of funny when you make the point that, well, yeah, if you just had more compute, it'd be more efficient. Or if you could fit more than 12 DGX units into a single system, then it would get more efficient. But these kinds of scaling ideas are really cool to see, even if you, in theory, can't really test that right. It's truly open, which, again, Apache 2 is basically one of the most open ways you can license software like this. Yes, we're looking at Anthropic, since technically you're not supposed to use that for anything business related right now, which is kind of funny. You can get their code right now. It's on Hugging Face. I'll link below. And again, it's really kind of up there in terms of benchmarking. They don't really want to talk about this shade of gray, which I think maps to Llama 370B when we look at kind of academic benchmarks. But I think what we're going to see more of in the future are kind of these realistic task benchmarks, because they show capability for the average user and, most importantly, for agentic tasks. And AI agents aren't just going to be doing a lot of math and common sense reasoning. They're going to be doing tasks that people want output for so they can replace employees for. Which, look, frankly, no joke, we actually had to hire one less intern this summer because we actually used some AI. So still hire interns, but the AI agents are getting there. And if anyone's working on agentic paths or workflows for system reliability engineers or SREs, please let me know, because I want to use that at my company. So this model is incredible. I think it's, maybe if it's not an entire win, it's at least a really interesting take on where mixture of experts might be going, especially when they're directly competing with the performance of Llama 370B. Now, the full Llama 3 400B model may just blow all of this out of the water and prove all of this to be kind of a waste of time, but at least after that, we know the resounding win here, again, is efficiency in inference and is making the most out of those limited GPUs and power cycles from all of the coal-fired power plants that we need to make all this happen. Now, of course, I hope those are replaced with nuclear, but we'll have to see where that goes. So, are you guys going to use this model? It's available right now. Are you worried that you just don't have enough GPUs to run this, even though in theory it's pretty efficient and we've seen some cool fine-tunes with this already? Let me know what you think in the comments below. I always love what you guys have to say. Apologies for the audio in the last video. Yes, that was my beard rubbing against the mic. Whoever commented that, I might try to get you some free GPU hours. But as always, I hope you learned something. If you like this video, please like, subscribe, and share. Helps us out a lot. And we'll see you in the next one.